My name is Marty Sanders. I'm the Executive Director of Growth Management, Intergovernmental Relations, Maintenance and Facilities. At St. Lucie County School District, we have about 40,000 students, 45 school sites, and about 6.5 million square feet under air conditioning. So it's a quite large school district, a lot of energy use, and we're in a hot, humid climate in South Florida. So air conditioning is one of the largest costs of our energy use. Some time ago, we started looking at how we could reduce our energy costs, and we put together an energy advisory team. We brought together engineers, architects, utility company personnel from both water and wastewater electric utilities, looking at what we could do to reduce energy costs for the school district. Part of the Energy Advisory Team recommendation was the construction of thermal energy storage. Our first plant, installed in 2009 at St. Lucie West Centennial, was very successful. We took our electric bill annual cost of over $600,000 to under $300,000 a year. And that was really the beginning of our thermal energy storage in St. Lucie County. Without a doubt, our partners, Trane, our engineers, utility companies, all brought these ideas to the table, and that's why we have thermal energy storage here.
We, over the years, have established a relationship with Trane based on the quality of their product, the reliability of the product, the service that we get, not to mention the support also behind the scenes. Through them, we came to find out in our design process about CalMac. After looking at CalMac and looking at some of the other manufacturers out there, we decided that it was no competition, that we were going to choose the CalMac tank based on a superior design and operation of those tanks. Since then, we've moved forward with nothing but Trane and CalMac because it's been proven to be successful for us.
We currently have 13 sites in operation. We have 2 others under design. So that's a third of our 45 school sites. One of the most interesting one is what we call our central plant. We replaced 3 chiller plants at 3 different schools with a central chiller plant and then piping that runs between those plants.
We decided to build a centralized plant and pipe to 3 schools, the Dale Cassens Education Complex, Dan McCarty Middle School, and St. Lucie Elementary School. We put over 2 miles of pipe underground at the site, which required a little bit of additional design in the beginning. However, it proved to be very beneficial. For very little increase in pumping power, we're managing to pump all 3 sites. This allowed us to reduce over 300 tons of chiller out of the system. We did this by designing at 60% of capacity in our chillers and 40% capacity in our tanks. For redundancy, we left St. Lucie Elementary School with the ability to change over and run the chillers that existed on the plant. This way, if there is ever a catastrophe where we do not have the ability to cool all of the schools, we will have the ability to shut down that site, run it off the original chiller system, and it will require less tonnage to cool the other 2 schools with the chillers that we have if the tanks were ever empty.
From the project point of view and the scheduling of this entire project for the district, we had a few obstacles. One, we only have a month and a half to do work during the summer. None of our projects could just be done over the summer without a lot of consideration about the temperature control, the safety for students, the access to the school, even athletic events at night and during the day. So we had to look at kind of out-of-the-box method of doing it. We don't have an opportunity to failure. Failure doesn't happen for us. So on this particular plant, we decided to build the plant separately, the central plant separately, 100%, have it operational, then pipe in and interconnect with the schools over weekends, holidays, so that we could maintain our continuity with the air conditioning system.
We've got a second utility company in St. Lucie County that does not provide a thermal energy storage rate nor does it provide rebates. So it makes the payback a little longer. And we've been able to design what we've termed a partial ice plant. It's not a full ice plant, but it basically does a good job of reducing the demand from that utility company. So we get a reduced demand rate. We also buy a smaller chiller. Combined with ice storage, we have some redundancy as well that's required in schools. So we've been able to be very successful with those plants without the rebates and without a thermal energy storage rate as well. We were ranked 60th of 67 counties in energy usage. As a result of thermal energy storage and other energy reductions, we've been able to reduce that to 18th in the state. That's important because we're not just looking at what we're doing. All the other counties have been in the same situation of needing to reduce their cost. So they've been very aggressive as well, but we've been able to reduce our rate much greater than they have and move from, again, 60th place to 18th in the state. When we started with the St. Lucie West Centennial Chiller Plant, we were at the highest energy usage of about $12 million a year in electricity cost. This past year, we just went under the $7 million figure. I look at that as a simple math that saves about 100 teachers' jobs.